Okay, so today, up to last week, we studied labor supply, and today we will study labor demand. So as you all know, the market, so at the end, the wages and employment level will be determined by market equilibrium. So since we learned the labor supply, so it's time to learn about labor demand. For the labor demand, we will go over the theory of short-run labor demand and long-run labor demand, and which are generally covered at the microeconomics course. So my plan is not to spend too much time on these two labor demand, short run and long run, and especially short run is very basic. So we will spend more time on the long run labor demand, which is much more interesting. And then we will deal with, actually I didn't write down here, 3 topics unique to labor economics, labor demand. One is about a little bit of policy exercise about the hiring quota in the textbook, and minimum wage, and the last one will be about adjustment costs. So we will learn about those topics today and Wednesday. Okay, let's start with short-term labor demand. Okay, so short-term labor demand, we start from the production function, as you all know, because labor demand is a derived demand, okay, from profit maximizing condition for the producers. So for the production function, we think of, in general, we think of a production function that uses capital and labor, okay? So E denotes the input, labor input, the amount of labor input. K is the amount of capital input. Okay? So yeah, so E and Q equals function. Q is a function of E and K. Okay? For the labor input, usually we use the number of employee hours. So that means generally the number of employees times the hours per person. Okay? Or it's a total of employee hours. And K, as you know, the capital, land, machines, physical inputs. Okay, when we make 2 simplifying assumptions, one is that at this moment we do not distinguish the number of workers hired and number of hours worked. Okay, so what we are interested in is a number of hours times number of workers. Okay, so we do not make a distinction between persons and hours, but we will make a distinction later, okay? And then we assume that all the workers are the same, homogeneous, okay? So workers are anonymous in a sense that they're basically identical to the employee, to the employers. Okay, and from the production function, we can define the marginal product of labor. Okay, so there is additional units of output produced by one more labor input, keeping capital input constant. Okay, so that is the very basic concept of marginal product of labor, and then we can define marginal product of capital in the same way. Okay, so this is the basic concept from production theory. Okay, so, and then obviously we assume MPE and MPK are diminishing. Okay, at first it may be increasing, but it should be diminishing. Okay, for the most part. Okay, and we define value of marginal product of labor. What is the value of marginal product of labor? Is simply the price times marginal product of labor. Okay, so by using one more labor input, okay, the producer can produce the output equal to marginal product of labor. How much this is at the market is the value of marginal product of labor, P times MPE. Okay? Questions? Okay. So that is the actually later you will see a concept called marginal revenue product of labor, MRPE. E make it smaller. Okay? Which is equal to MR times MPE. Okay? So these are two different concepts. So this is just the marginal revenue. So what the revenue brings, okay? How much revenue brings this marginal product of labor is. That's marginal revenue product of labor. Okay? And this is obviously same if the product market is perfectly competitive, then they should be the same. Because at the perfectly competitive product market, price equals the marginal revenue. Okay? But if it is not competitive market, they are different. Right? If it's a monopoly, which one is greater? If it's monopoly, then this one is bigger or this one is bigger? MRP is bigger? If it's monopoly, P and MR, which one is bigger? Right? P is greater than MR, right? So if the product market is monopoly, then BMPE is bigger than MRPE. Okay? So it will make some significant difference later when you think of labor demand of a monopolist. Okay? But for the time being, at here we assume that conveniently, let's assume that the product market is perfectly competitive. Okay? So in this case, we don't have to make distinction between VMP and MRP. Actually, we don't need MRP at this moment. Okay? So think of VMPE. Okay, and VMPK, we just similarly define. VMPK is P times MPK. Okay? And we can assume the average product. We can define average product of labor, which is average number of output units produced by one labor input, which is simply Q divided by the total labor input, E. Okay? So there is the difference between marginal product and average product. Okay? You should know it by now. Okay? If you're in the second, third year, you should know it by now. What the difference between marginal and average product of labor. Okay, average product of capital. Okay, let's draw a very simple production function. Here we assume that K is fixed. Okay, so we are talking about short-run labor demand. In the short run, okay, what is the short run? Short run is the amount of time the capital cannot change because it takes time to change capital input. You have to buy a new machine or you have to build a new building. All those things takes time. So, but it's much easier to change the labor input. For example, you can change the number of hours. Okay, you can ask your workers to work for longer hours, or you can cut down the long hours if you don't have to produce much. Okay, or you can change the number of workers. That can be done very quickly. Okay? But changing the labor, capital input takes much more time. So we assume in the short run, K is fixed. Let's say K is 0. So this production function shows a relationship between labor input and the output. And then this one has this shape, decreasing slope because of the assumption of what? What assumption? Diminishing marginal product of labor. Okay? So slope at each point is just a marginal product of labor. Okay? So that slope should be diminishing because marginal product of labor is decreasing. So at E0, this slope is the marginal product of labor. Okay, for example. And then the slope from the origin to E0 is the average product of labor. Okay. Questions? Okay. If you don't know what I'm talking about, you should, actually the textbook has much more detailed discussion about this, so you should try to read it, okay? So the textbook, our textbook, I'm going a bit quickly because I assume that you have already studied this in microeconomics, but if you're not sure, then look at the textbook. Textbook is much more slow, much slower, and then it gives very basic concepts much more in detail. So read it. Okay, so this is the one. For example, we can have an example. I will skip the example. Okay, now then the producers, obviously the objective is to maximize profit. Okay, so in the short run, we assume that K is fixed. So in this case, we think of a production function, the same production function. But actually, what matters for the profit maximization is the total revenue and the total cost. Okay, so total revenue is the P times Q. Okay, so since the market is perfectly competitive, we assume that P doesn't change. P is fixed. Okay, P is fixed for this individual firm. Okay, we are talking about individual firms' profit maximization. So for this firm, P is fixed. Let's say $10 a piece, something. So the total revenue is basically P times this Q. Okay, so it's gonna look like something like this. Okay? It's just $10 times this point. So it's pretty much has basically the same shape. Okay? So this is the total revenue. Okay, P times Q, total revenue. So this is how much they can get by selling their products in the market. And for the cost, we need to think of their total cost. Okay, total cost is obviously the cost of labor plus cost of capital. Okay, so in this case, cost of capital, let's assume it's fixed because you cannot change it. Okay, so even if they don't produce anything, they still have to pay the capital cost. Okay? And in this case, if they make more, okay, then they have to put more labor input. Since they put more labor input, they should pay higher cost. Okay? So if they let their workers to work for, let's say, 1 hour, or if they hire only one worker, then they pay the wage for that person. But if they want to produce more, they should hire more, or they should make the workers to work longer hours. Then they should pay more. Okay? So the wages are paid hourly. It's convenient to think that way. And so the total cost is just the RK0 is the capital cost, which is fixed. And WE is the labor cost, wage times labor input. Okay? So this part, that's the intercept. And WE is obviously this line. Okay? The slope is W. Okay? So the slope of this yellow line, the total cost line, is the wage. Okay? And what is the profit in this diagram? The profit is total revenue minus total cost. So in this diagram, that is the distance, right, between this black curve and yellow line. Okay, that's profit. So what the producer should do is to pick a point, okay, which makes the distance, okay, the greatest. So obviously this one is pretty bad choice, right? You can make distance longer. Okay. And you can try, and then obviously the way of doing it is to pick a point like D0, the slope of this yellow one, slope of this TR curve at D0 should be equal to the slope of the total cost curve. Then the profit is the biggest. The distance is the longest. So the profit maximization condition is the slope at D0 should be equal to W. So the slope at D0 is just the P times MPE. Okay? Because P is fixed, so you cannot change P. And so the slope comes from the production function, okay, which is the marginal product of labor. So P times MPE. So that is in one word, in one notation, we call it VMPE, value of marginal product of labor. So VMPE equals W. Okay? That is the profit maximizing condition. So E star is the optimal input, labor input, and profit is the distance between D0 and A0, and A0 to E star is the cost part. Okay? And total revenue is obviously okay. Get that? Questions? Okay. So you can read, this one much more slowly in the textbook, as I said, but it's not that slow. It has 1, 2, 3. It has 3 pages. So yeah. But anyway, it tries to explain it. So profit maximization condition, if it's every market is perfectly competitive, meaning that product market is competitive, labor market is competitive, let's say all the factor markets, capital market is competitive, let's say the employer, then the employee is a price taker, wage taker, and rent taker. Okay, so we assume every market the employer faces is competitive. So profit for a perfectly competitive firm is the total revenue minus total cost, which is P times Q minus WE minus RK. And in the short run, we assume K is fixed. Okay? And then we saw that the profit maximizing condition that is VMPE equals W. Okay? Actually, there is another implicit condition which is actually important. VMPE must be declining. Okay? This should be satisfied at the point where the VMPE is declining. If its VMPE is increasing, then this is not the profit maximizing condition. Why? Assume that VMPE is increasing. Then this cannot be profit maximizing condition. Why? Pie is getting bigger if you produce more, right? Okay, get it? Actually, if you think of a diagram, then you can easily see that why that is not condition. If the VMPE or MPE is increasing, then the production function gonna look like this, right? Not like that. What do you call it? Anyway, you flip the production function. Okay, this is like a MPE increasing MPE production function. Okay, which we do not assume. Okay, we assume this cannot be the case. But anyway, if it's true, then you draw a total cost line, something like this. Okay, that is not. I cannot find the point where this one is too steep. So I make it quite steep. difficult to find that kind of point. Should be very, very slowly increasing. Something like this. And draw a line, something like this, okay? And then if it's the same, it's probably somewhere here, I guess, okay? Then as you can see that obviously that if you produce more and more, the profit will get bigger and bigger, okay? It's simply because that marginal product of labor is increasing, meaning that if you put more inputs, then your output will increase at faster rate, okay? But you still pay the same wage to every additional worker, meaning that you can make more money by putting more workers, okay? Because they will produce more and more and more for the same cost, okay? So that cannot be the case. So VMP must be declining, okay? So if the marginal product of labor is increasing, that should mean that every producer, all the producers should be very big, right? Think about it. If the marginal product of labor is increasing, then the producer will make more money by making more and more product, by hiring more and more workers. So that means that the size, theoretical size of producer is infinite, okay? That is not really the case. That usually the firms will stop somewhere. Okay, that probably means that BMP must be declining. Okay. So this is a very basic condition that you should know that in the short run, BMP equals W and BMP is declining is the profit maximizing condition. So labor input will be determined at the point where this condition is satisfied. Okay? So think of short-term labor demand curve. Short-term labor demand curve is simply the BMP curve. Why? Because short-term labor demand is determined this way. Because the firm is wage taker, wage is given at the labor market, at W0. If it's W0, what does firm do? What firm does is that the firm picks employment level that makes value of marginal product of labor equals W0. That's what firms should do. They pick employment level to make BMP equals W0. Okay? So what it means is that that level of employment will be picked from BMPE curve. If wage goes up, then let's say wage is here, then if the firm looks at, okay, wage is higher, so how do I do it? Okay, I should change labor input to make the new value of marginal product labor equals to the new higher wage rate. So they look at value of marginal product of labor curve and find the point which makes the value of marginal product labor equals to W. That means for every level of wage, the firm will look at VMP curve to determine the labor input, which means VMP curve is the labor demand curve. Okay, short-term labor demand. So VMP curve is negatively sloped. Okay, because negatively sloped because diminishing marginal product of labor. Because of the diminishing marginal product of labor, VMP curve is negatively sloped. Okay, so automatically means short-term labor demand curve is negatively sloped. Okay, so mathematically, okay, you are given, let's say, production function that looks like this. And let's say P, price is $2 per piece. Now what is the short-term labor demand curve? Okay, basically the thing that you should know is that you assume K is fixed at K star, then you find the VMPE. Basically, marginal product of labor equation, that comes from the production function equation. Okay? So you differentiate, okay, product function with respect to E, then you get marginal product of labor. This is the marginal product of labor equation times price 2. Then you get VMPE equation. Okay? And VMPE equation should be equalized to W. Then from this equation, you just write everything with respect to E. That is your labor demand curve. Okay? So E equals K star divided by W squared. Okay? So the mathematically, the way of doing it is straightforward, given that production function is normal looking. So you find the marginal product of labor equation, okay? And given the price, just the P times that MPE equals W, and then you write everything. So E should go to the left side, and everything else should go to the right side, okay, right hand side. Then you get short-term labor demand equation. Okay? So if I ask you to do this at exam, I will give you marginal product of labor equation. Okay? So you don't have to differentiate, but you should do the rest. Okay? Questions? Okay, so far everything is very simple. So yeah, so using this we can. Everything is very simple. So individual firm labor supply, labor demand curve. You know. For example, we can draw labor demand curve for individual firm this way. Okay. Let's think of an industry that has 2 firms. Okay. So 2 firms, well, let's assume that everything is perfectly competitive. Okay. So we have 2 identical firms in the industry. So in this firm, for each firm, the wage is $20, then they will hire 15 workers, let's say. If wage is 15, they will hire 30. So we have individual labor demand curve. And think of industry level labor demand curve. So the way of doing it seems straightforward. So if it's $20, then we have 15 each, right? So 30 workers at the industry level. And if it's $15 per worker, then 30 each, so it should be 60. Okay? Because 30 plus 30 is 60. That's the usual way of thinking about it. But there, as the textbook explains, there is a problem in this logic. The problem here is that if we think of individual firm, the firm is perfectly competitive producer, so that's fine. Okay? So which means that each firm produces more, it does not change the price of the product. Okay? Let's say if $10 each, then if they say one firm hires more workers, okay, then they produce more. And then they supply to the market, but if it's perfectly competitive, we still have $10 per piece, okay, because it's perfectly competitive. However, think of this. Think of a whole industry, okay? So whole industry is different. Whole industry is, by definition, the monopolist, right? Think of this identical firm. They move together, let's say. Each firm makes independent moves, then that's fine. But if the firm makes the same move at the same time, all the firms, okay, then what happens is the whole industry will produce more. And the market cannot be perfectly competitive. Okay? If you think of whole industry as one entity, then it's basically it's a monopoly market. So if they produce more, the price should fall. Okay? Get it? If the price falls, okay, then value of marginal product of labor will fall. Because P times MP, P becomes smaller. So VMP will be smaller. So VMP is smaller. Okay? That means what? The workers will hire, I don't know, the industry will hire more and fewer. They should hire fewer workers. Okay? So, which means something like this. So, if it's 20, let's say, think of this. The wage is $20. So the two firms hiring 15 each. So we have 30 workers. So that's the starting point. Okay? But let's assume that now the wage falls 15. Then not only one firm makes more hires, every firm makes more hires. Okay? Since every firm makes more hires, then as I said, the VMP will shift. The VMP will drop. VMP curve will shift to the left. Okay? So that black one is a new VMP curve. Okay? Given the wage is $15. Okay? This is an industry level VMP curve. Think about it. Okay? So which means what? Now each firm will not hire 30, they will hire 28. Okay? So at first they intend to hire 30, but at the end it turns out that they will hire only 28. So that means the industry level labor demand curve is not the red one, it is actually a black one. Okay? It's steeper than just the simple sum of individual labor demand curve. Okay? Get it? No? So individual labor demand curve is still the red one. Because when they make the decision about their individual labor demand, they do not think the other firms will make the same move. So individual labor demand curve is still the red one, but when you sum them up, okay, if we assume the industry moves together, then we have a black curve. Okay? So in this case, we have, our industry level labor demand curve is different from the sum of individual firm labor demand curve. That one is this one is explained. Okay? Get it? Questions? Okay? So you should make a distinction between, the perfectly competitive individual firm and monopolistic industry. You have to make distinction between these two concepts. Okay, so what we have done so far is that we derived individual labor demand curve using VMP curve. Okay, and it seems to be fine. But let's look at an alternative way to approach labor demand. Okay, so what we do here is that to think of firms' output decision. How much? So far we have looked at how much labor input they will use directly. But here, let's make it kind of indirect way. Okay, first, let's think of the firm's output decision. Okay, how much output, how many units of output they want to produce. Okay, then labor demand will be determined by the amount of labor input to produce that optimal level of output. That is the labor demand. Okay, basically the same labor demand, but just the approach is different. So up to this point, we just look at directly how much labor input will be used using VMPE. But here we look at output first, and then think of the labor demand decision. So firm's output decision is, you probably, and you should know, the marginal cost should be equal to the marginal what? Marginal revenue, okay? So the marginal cost of production is the cost of producing an additional unit of output, and marginal revenue is the marginal revenue. But the marginal cost here, what is the marginal cost? Inside the marginal cost, so in this case, since the firm uses only labor to change the output, okay? So the marginal cost is basically the cost of changing the labor input. Okay, that's the only cost because capital is fixed. Okay, so the marginal cost is changing the labor. So how much it costs to increase, let's say, output by 1 unit by increasing the labor input, which that is the marginal cost. Okay, so then what is the marginal cost? Think of marginal product of labor is, let's say, 10, for example. So you have, which means that you have, let's say, 1 more worker, right? Then you will make 10 units. Okay, that's the marginal product of labor. Okay, make 10 units. Right? That makes sense. Okay? But if you want to make only 1 unit, okay, let's say you want to produce only 1 unit. Okay? Then how much input do you need? If 1 worker makes 1 worker, okay, 1 worker, divide 1 worker is different. So let's say each worker works for 10 hours. So 10 hours for 1 worker makes 10 units, okay? So you want to make 1 unit, then what should be used? Only 1 hour or 1/10 of 1 worker, okay? 1/10. Of. So what is 1/10? It is basically 1 divided by marginal product of labor, okay? So if we know the marginal product of labor, and just 1 divided by 1 marginal product of labor is the additional labor input we need to produce 1 unit, 1 more unit of output. Okay? So very simple example. So then what is the marginal cost? So marginal cost is simply the cost of 1 divided by MPE. Okay? What is the marginal cost of 1 divided by MPE? It's just because it's a labor input, it's just simply W times 1 divided by MPE. Okay? So you paid, let's say, 1 worker $10. You ask that worker, okay, you come here and then you do only 1/10 of your usual work, and then I will give you 1/10 of your wage. Okay? So that seems to be a fair deal. Okay? I noticed that you can make, 10 units. I need only 1. So you just do only 1/10 of your work. Then I will pay you 1/10. Okay? So that's how it makes. So W divided by W times 1 over MPE is the marginal cost. Basically the same. Okay, so what we know, marginal cost of labor, so the optimal output is marginal cost equals marginal revenue. Okay, if it's a perfectly competitive market, then we know that W divided by 1 over MPE is equals to P, because marginal revenue is the price. Okay, so this is how you make like a Q star decision. Okay? So to produce the output Q star that satisfies marginal cost equals marginal revenue, or W times 1 over MPE equals P, is the optimal output decision. Okay, and as you can see that this condition is exactly the same as W equals P times MPE, right? It should be. If they are different, then we are in trouble. Okay? So this marginal cost equals marginal revenue, or BMP equals W. Basically, they are the same conditions in two different expressions. Okay? So here we make output decision first, and then we just simply find the labor input that makes this optimal output. Here we just look at the labor input directly and find the optimal labor input. And that it will make the optimal output. Okay? So one way or another, basically the same thing. Questions? Okay? So the first way is to find the optimal labor input, and it will give you optimal output. The second way is to find the optimal output first, and then it will give you optimal labor input. Okay? Just go this way or that way, basically you will make the same decision. Okay? If you are making the right decisions. Okay? So we just saw they are the same, basically. Okay? So it will be convenient sometimes to think labor demand from the labor demand side directly. Or sometimes it's convenient to think the output decision first and then labor demand decision as the kind of subsidiary decision to output decision. Okay? Basically, we will think both ways. Okay? So that's why we are talking about output decision. Okay? Sometimes it's easier to look at output decision first. So in terms of diagram, it's going to look like this. Okay? P, MC curve, and output Q star. Okay? P equals MC. So in this case, for example, wage falls, then what happens? Okay? If the wage falls, then what happens in this diagram? Marginal cost gets lower, right? So MC curve will shift to the left or right? It should shift to the right. Right? Okay. For the same output, the dollars are lower. So marginal cost curve will shift to the right. So MC curve shifts to the right, so the optimal output will increase. Okay? So since the optimal output is increased, they should put more labor. So the labor demand will increase. Okay? At that? So it's kind of indirect way of saying that labor demand increases as wage falls. The wage goes up, then the other way around. Marginal cost curve will shift to the left. Optimal output will fall. So to reduce the output, they should put less labor. So wage goes up, labor demand falls. Okay? And that one is directly we draw like a VMP equals W curve. Okay? So to reach it, you can use this way. Okay? And price goes up. Then as you can see, the optimal output increases. So you put more labor. Okay? Okay? And price falls, and the other way around. Okay? Get it? How they are linked? Okay? You should know how they are linked. This curve and W labor demand curve. They are linked basically. How they are linked is a bit different. Okay? So when the wage changes, then MC curve shifts to the left or right. In the labor demand curve, basically it's a movement along the labor demand curve when wage changes. Labor demand curve, right? So if the wage changes, the MC curve shifts. But in this diagram, it's actually it's not the shift, it's just a movement on the labor demand curve. And the price changes, then it's a movement along the MC curve. But here, labor demand curve will shift to the left or right. Okay? That? Shift of curve or movement along the curve. Okay? So it's just a different. Okay. Now we covered short-run labor demand. Now let's move to long-run labor demand. Okay, this one is much more interesting. Why? Because in the short run, the only thing that can change is the labor input. So in a way, it's boring. It's very easy. It's boring but easy. Long-run labor demand is more interesting but a little more difficult because we have two things that can move at the same time. So in the long run, the firm maximizes profit by choosing labor and capital input, both. Okay? Okay, so to think of both inputs, labor and capital, we cannot use just a simple product and function. Okay? We use a little more interesting diagram. We call it isoquant. Okay, so isoquant is this one. Okay, so isoquant is simply the curve that connects points like x and y. X and y has different level of capital and labor inputs. Okay, so different capital and labor input, combination of labor and capital input, that produces the same quantity of output. That's why we call it isoquant. Iso simply means equal. Quantity is quantity. Okay, so it's a curve of equal quantity of output. So every point on the same isoquant curve gives the producer the same output. So you can produce, let's say, x and y. So x uses more capital, less labor. Y uses less capital, more labor. Because it's a long run, right? They can change capital and labor same time. So they can choose x or y or any point. Okay? Make sense? So isoquant curve looks like this. And it should be downward sloping, obviously. If it's upward sloping, okay, it doesn't make any sense. Why? If it's upward sloping, you put more labor and more capital and you produce still the same. Okay? That should not make sense. Okay? So to be on the same isoquant, if you increase labor, you have to decrease capital, or increase capital or then decrease labor. So it should be negatively sloped. And cannot intercept. Okay, if it intercepts, it's not good. Okay, why? Think of yourself. It's a simple logic that it shouldn't be intercept. Higher indicator, higher one, Q1, Q0, which one has bigger output? Q1. It's because more labor, more capital, so farther away, it should be more and more output. Okay, come back to the origin. Okay, that's what we assume. And then we define the marginal rate of technical substitution, MRTS, okay, which is MPE over MPK. Okay, so it's basically MRS, basically the same idea as the MRS, but applied to output, the producer side. So we call it MRTS. Okay, so basically this is a ratio to, if you, let's say, put more capital, okay, and to be on the same isoquant curve, to still produce the same output, by what rate the labor input should be decreased. That is the MRTS. Okay. Questions? So isoquant, as I said, it's a in a way, it's like indifference curve. It's very simple. And looks like indifference curve, okay? But it is the output thing, okay? Okay, then we need another thing. So here we talked about the output, quantity of output. Here, let's talk about cost, okay? So we introduced the concept of iso cost lines, and iso means equal, right? So iso cost is equal cost, okay? So equal cost, it should mean that combinations of labor and capital inputs that cost the same amount of money to the producer, that's iso cost, okay? So iso cost indicates equally costly combinations of inputs, okay? So higher iso cost, okay, so it's going to look like this, okay? So for example, like total cost is C0, okay? Then one way of using C0 is to not to use any capital, just to use labor, okay? Then your labor input should be C0 divided by W. That is your total labor, okay? You use only labor, okay? Then, you have $1 million. Each worker is paid $1,000. Then you hire 1,000 workers using $1 million, okay? So that is this. The other extreme is obviously just replace everything with machine, let's say, okay? Then zero labor input and total capital is C0 divided by R. Let's say each machine costs you $10,000. Then you have $1 million. Then you can hire 100, not hire. You can use 100 machines and no workers, right? So that is this one. There's two extremes, but we have combinations in between. Some workers, some machines. That is this line. Okay? So obviously that you want to hire more workers, so you spend more money on workers, then you can use less capital, so it's negatively sloped. Okay? So C0 and C1, obviously which one is bigger? C0, C1? C1 is bigger. Okay, cost is higher. So you move away from the origin, then the cost gets higher and higher. Okay? Then what's the slope? Slope? Slope is W over R. Okay? So given this triangle, you can get the slope, which is W over R. So in my example, like I said, each employment costs you $1,000. Each machine costs you $10,000. So the slope is 1/10, okay, in this case. Okay? And it's negatively sloped, obviously. So, but anyway, W over R. Okay? Question? Okay? So once you know the isoquant and isocost, okay, then you can solve cost minimization problem. Okay. So in this long run labor demand, we approach long run labor demand in two stages. At first, okay, we look at labor demand given an output. So at first, let's assume that the firm determined the desired output somehow. So let's say the firm decided, okay, what I should produce 1 million units, let's say per month. Okay. So what the firm should do is that, okay, I will produce 1 million units per month. Then the firm should find the most efficient way of doing it, right? That should be the firm's goal. Okay? What is the most efficient way? In this case, it must be minimizing the cost. Okay? What is the cheapest way of producing 1 million units per month? Okay? So we don't question why they derived 1 million units per month. We just assume it is given. Then we ask the question how the firm should do it. Okay? That is the cost minimization, as I said. And then we can derive labor demand from cost minimization. And we call it conditional labor demand. Why it is conditional? Because it is conditional on the desired output. Okay? So if the desired output changes, then labor demand will change. Okay? So this one is the middle way. Okay? It's a first step to get to the long-run labor demand. So in this case, that's how we do it. Cost minimization given the output. Okay? Then we ask, what is labor demand given that output? Okay, cost minimization is actually, if you look at the diagram, it should be straightforward. Okay, cost minimization, we said that the firm wants to produce a fixed output, Q0, let's say 1 million. Then what should the firm do? Okay, the firm has isoquant curve. The firm can choose anything, any point on this curve. It will give the firm 1 million units per month. What is the best way? The cheapest way. Okay? Then they should look at the cost at each point. And how do they do it? We just introduce isocost curve. For example, point A and B. Those 2 points are on this isoquant line, isocost line. Okay? So it produces this much. Okay? So is this the cheapest way? It is not, right? If they move isocost line inward, we can see that it can still make production of 1 million units per month still, but costs less. So we just push the isocost line to as close as possible to the origin, but it should not go beyond it. So we reach a point where? This point, P, right? Point P. So this point P is the cost minimizing way of producing Q0. So what's special about this point? At this point, 2 slopes are the same, right? Which and which? The slope of isoquant is equal to the slope of isocost. Okay? So that is what? That is the cost minimizing condition for to produce output Q0. Okay? So the firm will equalize the 2 slopes and find out that, okay, 100 units of labor, 175 units of capital. This is the cost minimizing way of producing Q0. Okay, so that is the choice. So MRTS equals W over R, or we can say MPE over MPK equals W over R. Okay, so this is the slope of isoquant, slope of isocost. The implication is actually pretty simple. The last dollar spent on labor should yield as much output as the last dollar spent on capital. If they are not the same, they are doing something wrong. Okay? If they are not the same. Okay? If labor gives you more output for the same dollar, you should increase labor input. Okay? If the capital gives you more output for the same last dollar, you should increase labor capital input. Okay? So you are not doing optimally. At the optimum, they should be the same. So MP over MPK must be W equals to W over R. Okay, MP over W equals to MPK over R. It's the same thing. Okay. Okay. like section 3-3. So you read about it. Basically, that's what I basically covered. So mathematical output, we can use the same production function, Q equals EK, and then let's think of labor demand, conditional on Q0. So here what we need is MPE over MPK, okay? So we need to get MPE and MPK equation, and MP over MPK is K over E in this case. And cost minimization, it's a simple K over E should be equal to W over R. Okay, that's fine. Okay. So, but there is a thing is that conditional labor demand given on Q0, okay? So that means that not only this condition is satisfied, but also the output should be equal to Q0. Okay? So that means that there is additional condition that Q0 should be equal to square root EK. Okay? So Q0. So first condition is that K over E equals W over R. Second condition is that Q0 equals square root KE. Two conditions should be satisfied at the same time. So that one is that means basically means K should be equal to Q0 squared divided by E. Okay, this comes from this one. So we put this one into K equation. Okay. And then you write everything with respect to E, then we have this. Okay? So to the right hand side, we have Q, R, W. Okay? Output, desired output, rent, and wage. Okay? No K. Okay? There is no K, right? K disappears because of this condition. So this is we call the conditional labor demand curve given Q0. Okay, so if we know that Q0, let's say, is 100, R is $4,000, wage is 1,000 bucks, then we can, find the optimal labor input with 200 units. Just put everything into the equation. Okay, now let's think of this. Let's see what is the effect of wage, change in wage on conditional labor demand. Okay. So here we have Q0 and the slope of W over R, the initial slope. Okay. Let's assume that W becomes lower, wage got lower. Okay? Actually, the other way of looking at it is that rent goes up. Okay? So what matters here is not the level of wage, level of rent. It is actually ratio of wage to rent. Okay? That's what matters, actually. So when the wage changes, obviously the ratio will change. Because in this case, let's say wage falls. When the wage falls, then this isocost line becomes flatter because W over R becomes smaller. So it becomes flatter. Okay? So what happens? The optimal point is not P. It should be R. Right? So moving from P to R. So labor input, what happens to labor input? Increases. What happens to capital input? Decreases, right? So labor input becomes relatively cheaper, so you put more labor. Capital input relatively more expensive, you put less capital. Okay? So when the wage falls, this will happen. When the rent falls, when rent goes up, then basically the same thing gonna happen. Rent goes up, then labor becomes relatively cheaper because rent is higher. And capital becomes relatively more expensive, so put more labor, less capital. Okay? So this is what? This is substitution. Okay? So in the conditional labor demand, which is, you can say it this way, right? The conditional labor demand and wage, they have what relationship? Conditional labor demand and wage, if everything else equal, conditional labor demand and wage should have negative or positive relationship. Should it be? Negative relationship. Wage goes up, conditional labor demand falls. Let's say everything else is equal. Let's say capital rent doesn't change. Your desired output doesn't change. Okay? Only wage goes up. Then you substitute capital for labor. Okay? So labor demand falls. And the other way, labor demand increases. So in the long run, conditional labor demand is negatively sloped. So conditional labor demand curve is negatively sloped with respect to wage, but also you can draw a labor demand curve, not the labor demand curve exactly. You can draw a optimal labor input with respect to rent, right? So rent goes up, then labor demand increases or decreases. It should increase. Rent falls, labor demand decrease. Okay? Because substitution. Oh, this part. Total cost of production. Think of this way. Think of this. Let's say wage falls. Okay? Let's say rent was fixed. Only the wage falls. Then we know that it moved from P to R. Then ask the question, what happens to the total cost? Is it higher or lower? It's difficult to tell, right? If you look at this one, because they cross each other, so it's difficult to tell whether this is lower cost or this is lower cost, right? If it's not like a move farther away and closer. But it's a simple way of looking at it. Think of this way. Okay, well, this is capital. This is labor. At this point, we know that this should be equal to C0 over R. Okay? This is the extreme point. Should be C0 equals divided by R. Now, wage falls. Okay? Rent doesn't change. Then this slope will become flatter. So you draw a new point, new isocost, should be something like this, right? So this is P and this is R, okay? Then you have this point, right? So at this point, we call it C1, some cost, total cost, over what? What is the denominator? It's still R, right? Because rent didn't change. So then which one is greater, C0 or C1? C0 must be greater. So C1 is lower. So when wage falls, total cost will fall. Okay? Get that? Look at this points. Okay? I mean, intuitively it should make sense. Wage falls. It should not cost more, because wage fell. It cannot cost you more. Okay, the worst is probably the costing the same amount of money, but it doesn't make sense that one either. So it should be the only one way. Okay. But things get a little more complicated if wage and rent changes, right? But, to the opposite directions. Okay. Or they change the same way. Okay, if the wage and rent goes up together, but their slope becomes different, then it becomes a little more complicated. You know what I mean? Wage falls and wage goes up. Now I'm getting confused. Wage falls, rent goes up. Okay, you figured that out. Okay, wage falls. Okay, so basically the basic way of looking at it is to look at these extreme points. If you look at these extreme points, then you can get a pretty good idea that which one is greater. Okay, the total cost. Okay, I think we should stop here today, and let's continue on Wednesday.